Module, we're going to start exploring in more detail the object-oriented programming nature of Python. We've been using the object-oriented nature of Python throughout the class as we use string methods, list methods, etc. But now we're going to get into the opportunity for us to define our own classes and thus to really customize the programming environment that we work with. And classes are another example of abstraction and code blocks, in that with a function we took code that worked together, statements that work together to a narrow common purpose. We put that in a function which allows us to reuse it again and again without repeating the program again. Modules let us take, with modules we took functions that had similar purposes, put all those functions into a module that then we could import into some other function that we're using. And classes fall into the same category. We're putting together something that we will then have for later reuse. But with classes, we think about putting our data and our functions to manipulate that data together. But a similar kind of thinking will go through in terms of abstracting what goes together, what should be part of a class, what should not be part of a class. So to kind of introduce the thinking through object-oriented programming, we're going to go back to the ancient Greeks, which of course is where the name Python comes from, even though it comes to us via Monty Python. And the two key ideas that I try to keep in mind with Python and object-oriented programming are two lines that were inscribed at the temple at Delphi. The first is nothing in excess, and then know thyself. So let's talk about these first. Okay, nothing in excess. So Python takes a very pragmatic approach to object-oriented programming. While everything in Python that Python provides to you is an object, Python does not require you to write an object-oriented program. And we've already seen that because we've been writing all sorts of functions without making use of our own classes, etc. And this is rooted in the understanding that object-oriented programming is good for lots of things. One of its real strengths is in computer graphics. But not every solution calls for an object-oriented approach. A lot of scientific programming is still procedural programming may be a better fit. Functional programming has become very popular recently, and Python will let you write a functional style programming class. So essentially, Python lets you write programs that best fit the nature of the problem that you're tackling. And so classes can be used when needed, but we should try not to use them in excess. I certainly went through a phase where, I was so excited, I know how to define classes. This probably goes back to when I was really working in C++, and so I'd write a class for this, a class for that, and I really kind of became excessive in my use. And if I step back and look at the core language, oftentimes what I was writing a class for to do something specific, a dictionary would have worked just fine and probably had made my code simpler. An approach taken in this book that I have a link to, Functional Python Programming, where they're trying to advocate not an object-oriented programming paradigm, but functional. What they'll do a lot is take a built-in structure like a tuple, and they'll just write a very simple class around it that maybe provides some printing methods, some things to make the interaction a little more intuitive for the particular application, but isn't really changing its tuple nature. So we're using classes to extend the capacity of a common data type to make it a little more user-friendly for the particular application we're working on. Okay, the second concept, or second Greek concept of object-oriented programming is know thyself. And this reminds me again of my friend from graduate school, Mark Thomason, who gave the definition that I still really like a lot, that an object, that which we create with the classes that we define in object-oriented programming, an object is an entity that knows itself. So the object knows how to do all the basic functions associated with it. So if we think about this in Python, a list object knows how to print itself, it knows how to insert an object into itself, knows how to append. So we don't have to call some other function to append something to a list. The list knows how to do that appending process itself. So when we say that an object knows how to do something, we mean that it has a method that performs a particular function. Another way that I kind of think about this same idea is that objects allow us to wrap together data and all the relevant functions for interacting with those data. So whereas before we've defined named tuples, we've thought of how we would want to represent lab data, for example. The object-oriented programming goes one step further. Okay, now that we've decided that we want our lab name to be a string and our range to be a tuple of integers or floats, in thinking about a class, we would now think of, well, what methods would we want to be associated with those data? Would there be a method to render the lab report? Would there be a method to identifying that there's a critical value and an alert should be sent? Or is there a method that would tell it how to save it to disk, for example? So there's some other important characteristics of object-oriented programming that we can keep in mind. One of these is polymorphism, and this is from the Greek word for having multiple forms. And this aspect of object-oriented programming allows us to write programs with similar form regardless of the underlying representation or nature of the data. So polymorphism enables us to use methods of an object without knowing its class type. So we can add things together. And the addition has different meaning depending on the object. So addition with strings means concatenation. Addition with integers means arithmetic addition. Similarly, we have a concept of a length, and it doesn't matter whether it's a list or a string or a tuple. So that's polymorphism. Another concept is encapsulation. So here's a quote from a textbook I've used in the past. Encapsulation is the principle of hiding unnecessary details from the rest of the world. Encapsulation enables you to use the object without worrying about how it's constructed. So encapsulation is hiding from the user details that the user doesn't need to know about. And this makes it easier for us to maintain our programs as we decide on a different or hopefully improved underlying representation of our data. That we change that can hopefully not affect the programs that someone's using with our class, because the details of underlying representation aren't something that they need to worry about because of they're interacting with the data through the class, but not the data directly. And the second idea is inheritance. And this is that we have groups of objects that have similar characteristics with more or less detail. And so what we will do is we'll define a class for the most basic characteristics of something, and then we inherit, so we make a more complex class that inherits all the characteristics of the parent class but adds new details to it. So if we think about this in terms of like computer graphics, we would have a general concept of a 2D shape. So we might have a class for shape. And what would be some of the things we might think about with shape? Well, it could be, all 2D shapes have an area. All 2D shapes have a perimeter. Well, we could take a 2D shape and we could inherit from that and have a class of a circle. Now, a circle is it's a kind of a 2D shape, but it has has a specialized concept of a perimeter that we would call a circumference. We could go from shape to the idea of a polygon. And a polygon, we would now have a concept of the number of vertices that we have, and that's something that we don't have with an arbitrary 2D shape or with a circle. Similarly, we might think of a series of inherited classes where we have a base class of a person. A person might have a name, an age, physical characteristics. And from person, we might define a class patient. Well, a patient is still a person, but with the concept of a patient, we might have an idea of problems, what's our medical history, who's my provider, what kind of medications am I on. And similarly, we might inherit from a patient and create a more complex class of an inpatient, where here I would have what's my admit diagnosis, what ward am I in, etc. So we start with something that's fairly general, and we move to something that is more and more specific in our class definition that would be used in some particular application. We've talked about this before, that there's multiple programming paradigms, and Python facilitates all of them, does better at some things than others. But again, just kind of to repeat that in Python, all intrinsic types in Python are objects. We see that they all have attributes, and they all have methods. And so now what we're going to step forward in this module is learning how to define our own classes and define our own attributes and methods.